Alright, this is test review number 1, reviewing problems 31, 35, and 34. Alright, so with these, this is a whole number multiplied by a fraction. All you need to do with the whole number is to make it improper. And what that means is this number becomes 25 over 1, because any number over 1 is just the same number. In other words, 5 over 1 is 5, 6 over 1 is 6. So it's just a different way of writing a whole number, really. You can write a whole number as a fraction just by putting it over 1. And now you can continue with the multiplication, and it's easier. It helps you to keep track of what you're doing. Multiplication is always the numerators are multiplied and the denominators are multiplied. You do not have to find a common denominator, and you should probably make a note of that somewhere, because oftentimes when you're doing a test you might get so wrapped up in finding common denominators you won't realize you're starting to do it with multiplication. And I see that happening on tests, and then it becomes too much math. It doesn't make it wrong. You could still get a right answer, but it's a lot more math than you need to be doing. Okay, so you multiply the numerators. 25 times 2 is 50 for a new numerator. And then 1 times 5 is 5. Now we need to reduce to the lowest terms. And when we do that, this is an improper fraction because the numerator is larger than the denominator. So we have to divide 5 into 50 to create a mixed number. And I just did a video on mixed number, changing an improper fraction to a mixed number. That's question number 25, I believe. It's 24 or 25, but it's on that video. So then 5 goes into 50, and we know that that goes 10 times. 10 times 5 is 50. You have no remainder. So you just have the whole number 10. And we learned in our last video, or in that other video, that the number that you come out with on top here in the division is the whole number. This remainder, just as a reminder, that sounds kind of funny, is what makes a new fraction. Well, when we make a new fraction, this would normally be a numerator. That one is normally a denominator. But in this case, if you were to put the numerator over this denominator, the numerator of 0, over the denominator of 5, that just equals 0. Alright? That's not undefined. This equals 0. It's okay to write this. So we don't need to have any remainder. We have no fraction left over. We just have a whole number. So when you reduce this fraction, what you get is the answer 10. That's the whole answer. That's the final answer, as it were. I like to box my answers in red. So that right there is the answer to number 31. And let's just put it over here. The answer is 10. Okay, in this division here, the process for division, and you should write this on a little card and try to memorize these things, is it's 2 steps. You're going to take the division sign first and turn it into multiplication. Let's give you color here. Arrow, and an arrow, This turns to multiplication. That's a dot for multiplication. And this becomes the inverse. So it's 8/5. You have to turn, it's 8/5 turned around to 5/8. So your problem is no longer division, but multiplication. So all division for fractions turns into multiplication. So let's make that a little clearer. It becomes, always leave this one alone. 2/9, leave it alone. So think in your mind, first one, leave alone. Second thing, change. We're going to change it to multiplication, and I'll make the X here. And the next one, you turn it upside down. Okay, so the first thing stays the same. The sign or the function changes, and the fraction, the next fraction changes. And it's just regular multiplication, just like up here. Multiply the numerators, multiply the denominators. So 2 times 5 is 10. We've got another 10, and over 72. Anytime you have even numbers, you know you can keep dividing to reduce it. So let's do that. I'll use a different color. I am going to divide 10 by 2, and I'm going to divide 72 by 2, because you always, when you're reducing, have to divide the numerator by the same number as you divide the denominator. You can't choose different numbers. And that's going to equal 5½ of 72. So 72 divided by 2 is 36. And that fraction then is reduced. So our answer there is 5/36. Now over here, what it is this big fraction line becomes the division sign. So again, you're going to have to take the first number doesn't change. We're going to make the division sign. And when we're setting it up, just leave that one alone. We're not doing anything yet to it. We're just turning it into a horizontal problem. And all you have to remember is this goes first, then the division sign, then the denominator. Now it's horizontal and we know what to do. We do the same thing we did here. We start out with changing things. 5/13 stays the same, so I guess I shouldn't say we start out with changing things. We start out with leaving the first fraction the same, then we change the division sign to multiplication, then we change the fraction to the reciprocal, which means you turn it upside down. So then it's 39 over 35, which is a very nice thing for us, because this 13 goes into 39 and 5 goes into 35, and that's cross cancellation, which I want to show in another video on a problem that students have been, some people have done it more complicated than it needs to be done, and that's problem 30, so I'll show that on another video. Anyway, we're at this step here, which is we can use cross cancellation, and how we do that is 5 into 5 is 1. Divide this one by 5, and that's 7. What you can do is look at the diagonal. That's only for multiplication, not for addition, not for subtraction, and not division, because division always turns into multiplication. So it's only for multiplication that you can cross cancel. And then 13 into 13 is 1, and 13 into 39 is 3. So then we have 1 times 3, which is 3. 1 times 7, which is 7, and we have a nice reduced answer. If you didn't do the cross cancellation, you would have done 5 times 39, which would have been a large number, We can pull up the calculator and look at that. So 5 times 39. And when you're not working with a calculator, you would have had 195. And when you're not working with a calculator, these larger numbers are more cumbersome. And then you would have had 13 times 35, which is 13 times 35, or 55. And you would have had that, and you would have to reduce. You have to reduce this large fraction to get down to 3/7. So then you have to sort of sort out in your head, well, what am I going to divide by to reduce to 3/7? I would start with 5, and once you start there, you'll find you might have to do more. 195 divided by 5 is 39. So you would divide by 5, and we could keep going, but I don't know if we need to because you already have the answer. But just in case some people did it this way, if you divide it by 5, then you have 39 over divided by 5, 91. 91, goodness. My guess is you can divide by 13 next. Yeah. So then our last division, you divide by 13, both the numerator and the denominator, you will then get 3/7. So 3/7. So if I multiplied 5 times 39 and got 195, then I'd have to divide by 5 and then again by 13 to get 3/7. In this situation with the cross cancellation, did your reducing really before you multiplied. And that's what cross cancellation is reducing before multiplying. It's just not reducing a fraction with the numerator over the denominator directly. It's sort of diagonal. The numerator is over the denominator, but it's on a diagonal. So it's a diagonal fraction, if that makes any sense. I hope it does. Alright, so problem 30 will show cross cancellation again. And this is how you solve 31, 33, and 34.